Microgrid in a box, in essence, focuses on taking what are the usual key generators, both in terms of storage and generator devices, as well as the key consumers of electricity in the household, which would be your heating or your cooling system as your primary, and collapsing that all into one system. And rather than having AC as our connecting option and then having the conversion from AC to DC at every single one of these devices, we actually turn it into a DC backbone. So the idea behind the system, in a nutshell, is that you have a high voltage DC backbone. Again, this is in excess of 1,000 volts. We don't quite know exactly where we're going to land. There's a number of factors that actually play into that. So there's a DC backbone, which has one core AC DC converter on it, which will differ in size dependent on the requirements of the household. And then it has DC components on it. So it will have an EV charger, which is DC. So there's a DC converter there. There's an MPPT or a set of MPPTs to enable your PV connection. And then there's obviously an inverter to connect to your battery as well as a DC-DC converter. And also, this is an interesting one, a connection to your heat pumps. What's not commonly known is that the majority of heat pumps available in the market, the vast majority, can be run without modification on 350 to 420 volt DC, and very efficiently too. And when we talk heat pumps, we're not talking just about house heating and hot water. We're also talking about the next generation air conditioning units that use heat pumps as well. So we now have an opportunity to drive your major electricity consumer, both here as well as in electrification environments where you use heating, like Europe or Tasmania for that matter, or New Zealand, where you want more heating. In those locations, you would be able to run those directly and control them as well.